I just made trouble and simplified the brain. What happened was we were trying to do something about, oh great, cuts the foil. Whoever's controlling this would be nice if we could see the left-hand edge. That's the projector side. But anyway, thank you. There we go, a win, almost. And so what we did is we put a beacon, a BGP speaker, somewhere in the internet, and then we observed its behavior from far away at some observation points on the internet because we wanted to study BGP behavior. And we figured what we'd do is we would, we're looking for transient instability, router reboots, link flaps, etc. And so what we do is we'd announce the route. The route would become available. You'll notice it was, 192, whatever. It's a swamp 24. So it should be visible everywhere and get around Nazi filters like that nasty guy Randy Bush puts up. And announce the route for an hour, drop the route, withdraw it. Watch the withdrawal propagate, keep it down for 1 hour, bring it back up again. The route should be available. We were, oh great, we were horribly surprised. The route was suppressed. The route had been damped. It was not visible to most of the observation points. This was an hour, okay? What's route flap damping, just to review? It's got an RFC. The problem was a bunch of routes were flapping, routers were getting too overly excited and weren't taking and acting nice and restfully and making messes on the internet. And so way back in about 94, Sean said enough. A bunch of people started drafting stuff to damp the routes, okay? And the goal was to reduce the router load and keep convergence time reasonable for the routes that behaved well and punish the ones that didn't. And the idea is there's an exponential curve, and as you misbehave, you accumulate penalty points, and once you cross the threshold, you're out suppressed, and then it decays in time, and it gets below a threshold, and it's reused, and there are all these parameters and all this kinky stuff, and the two major vendors have, here's the values of the constants in their algorithms, and they're pretty much the same, just a little different. And it's supposed to be that 3 flaps would suppress the root. Okay? In other words, the first 2, withdrawal, a re-advertisement, etc., 2,000. So then the third, blam, you're dead. But the problem is what we're seeing is, if you remember Abba and Craig's stuff of a year or two ago, is, let's call out, for the moment I'm calling it a Hooja crankback, is this is just the result of one withdrawal. The withdrawal happened at 1800, okay, and over the next 4 minutes as that withdrawal propagates throughout the internet, we see routers converging on alternate paths. The withdrawal happened, so it said, oh, well, this path is still there. Oops, I can't get there, but that path is still there. Oops, I can't get there. There's an alternate path through 5400, 3320 instead of, oops, there's a withdrawal and out. And with one withdrawal, there's 3,694 points. The route is now damped at any distance. And this is short distance, by the way. These both are within the lab. That's the source, origin. This is within the lab. This is the upstream ISP. So the path is really only 4 significant ASs changing. You're not far from that point, and you're getting damped. Okay? Here's another interesting one. When one of the differences, you can't see a difference between these two. The difference happens to be a community attribute. As it came in one side of the 3257 ISP as opposed to the other, and so it got a different attribute marking because of the way that ISP configured things, and we saw it upstream from that, wham, suppressed for, an hour and a half. Okay. Why does it happen? The exploration of alternative routes, what I was calling Haber-Leibowitz crankback. It's dependent upon the topology, the richness of the topology. The richer it is, the more interconnected ASs are and routers are, the more likely this is to occur, the worse it is. There's delay in message propagation due to the min-route advert, propagation and router processing, and then there's the settings of the parameters. Okay? And we hypothesize that the default settings are too aggressive. Let's look at what we mean by the results that can come from crankback and propagation of routes along varying paths, to understand a bit more about how this happens. The naive view we have of some connected speakers, BGP speakers, is an announcement and a withdrawal comes into this router, and it talks to some cloud of routers, and if we look at this router, there's the announcement and there's the withdrawal out of router 17, and here's the announcement and withdrawal out of router 23. But that isn't what happens. If we model this thing, and we actually look at it, and I'll show you a quick overview of the model in a second, the announcement and withdrawal comes in here, and if we look at this observation point, we see that. Announce, withdraw, announce, 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 withdraw. For the one announce withdraw pair. Okay, and Craig and Abba's paper and presentation they did here the other year covers this pretty well. But so Tim sets out to model it. And he says, what if we view each of these BGP speakers as something that takes some inputs and non-deterministically produces the outputs? So we don't, if there are two input paths to it, we don't know which order it will take those data in, if order is important at all. And in fact, the particular model doesn't even do ordering. There's no time concept. Okay, we completely abstract BGP, the protocol, out of this, and we just look at these speakers as blobs that take input sequences and generate output sequences. And we hook them up in a simple 5-piece path. And we're trying to observe point 1, router 1, from router 5. And router 5's path to get to 1 can be 531, 5431, 5421 are the valid paths there. Okay, and so on and so forth. And we inject the announce, withdraw at the top. And the little mathematics tells us that at the bottom, these are the possible resulting sequences. 52 different possible resulting sequences at the bottom for that simple topology. On odd-numbered Wednesdays, you'll get this one. Friday afternoon, you'll get that one. So on and so forth. Every time, you don't know what you're going to get. Due to timing, min-route adverts, and ways along that path, they're going to be more likely to get one than the other. But all those are possible. And when you look on the internet, you see all those, or most of them. Okay, in simple real topologies. So when somebody shows us a graph of a picture taken down here and shows us route flapping, and they try to tell us what caused it, they're looking at these 52 different sequences and trying to tell you what happened up here. They haven't got a chance in hell. Okay? So what we're seeing here is some of these sequences are long enough to cause damping 2 hops away in the simple topology. Okay? No fun. These are using the beacon back to real data. Okay? These are the maximum number of updates received at different peers. These are just measurement points, these peer IDs. The x-axis is different measurement points. The y-axis is for one announcement, how many different announcements were heard at that measurement point. Can the legend be read by everybody? That's about 17 up there. That means this one received 17 announced that there were 3 different beacons on the net. So for this beacon, this peer got 17 different announcements. That route was damped till 2040 AD. Right? Here's withdrawals. Same scale, a little worse. Withdrawals cause more excitement. Okay? There are withdrawals causing 22 or 22 and a half announcements is what it looks like. I don't think we have half announcements. Again, you'll be damped forever. So, multi-homing won't save you. Damping is not per pass. Damping is per prefix. So you've got 2 pipes out there to get redundancy and reliability. This one bounces. They're ignoring both. Damping loves more paths, as a matter of fact. Multi-homing gave you more paths. You thought you were getting more reliability. You're getting less. Okay? By the way, feel free to interrupt any time with questions, throw fruit. I was a little light on it at lunch. Whatever. Some preliminary ideas on what to do. Change the constants. You know, we can decrease the suppression thresholds, decrease penalty increments, and especially for attribute changes, etc. We can change the entire algorithm. Do not point laser at remaining good eye. Change the algorithm. Do we need damping at all? What would happen to the internet if we turned it off for a whole day? And you know, somebody, I think Teasley said, hey, we could take it in the big ISPs in the core. It's the edge that's going to die. Customers have pretty wimpy routers. The multi-home, many of the multi-home, small multi-home BGP customers. So the core could probably handle it. It's the edge that's going to die. But I mean, and from a debuggability, understandability, you know, what the heck's going on in the internet basis, note that route damping is opaque. It's this hidden thing that happens inside the router. I have no visibility into it, right? And it happens, when it's happening to me, it's happening over on the other side of the internet. So it's something I can't debug very easily. All of a sudden, all I know is I've got a customer calling me and they can't reach Aunt Charlie. So, you know, this is not a nice protocol thing where you can, you know, kind of, and BGP hides a lot of information, but at least, you know, you've got a route views and parts, you know, this isn't going to help you with this one very much. So, something's got to give, and I have no solution in the next port, or the one after, either. Okay? To give you an idea that we have 3 route beacons and where they're hiding, just a couple of us just put them in our labs is all. So, you know, I've got one in my lab. We put it up in August. And here are a couple others. For those of you who are doing research and looking for very controlled announced withdrawals on the internet, they're announcing it 3 a.m. and going down at 1 a.m. and every 2 hours thereafter. Now it's wait 2 hours, withdraw 2 hours, because 2 hours gets you past the route damping fairly far away. Not all the way away. You go, really the other side topologically of the internet, and you're still going to get down. There's the problem with changing the constants is this is proportional to distance and richness. Right? It's not simple. Okay. Here's 2 pages of references. The foils are all available on net there's the URL. How many of us route damp? How many of us don't? How many of us don't route? It's an interesting question what to do about this, but certainly for the moment the parameters are a bit aggressive, and it would be very nice if the folk whose names are on the RFC and whose names are on the right document would take a look at some data like this, or at these data, and give us some suggestions. Go, Anchor.
Ready. Yeah, just one clarification there. When you mentioned that the dampings apply for prefix, actually it may be true for some implications, implementations, but that is wrong from design point of view. Actually, from my understanding, that's not what the code should behave.
So that's changed the algorithm.
Well, the algorithm actually, if you look at Curtis' paper, it should be for path-based, not for prefix-based. And as far as I understand, the code actually, the deployed implementations does just that.
Which part of the path? Which part of that path?
Basically, if you receive let's say receive updates for prefix from multiple peers, the state is maintained for peer, for path, basically.
For first hop. For
right.
the first hop.
Right. That's correct. Yeah. Right. If it's beyond that, then it's very hard to tell. Yeah. For the first hop, it is for path based.
That's not what 2 of the more popular router vendors are doing, I assure you. You're suggesting others are? Are there actually implementations that do it that way?
As far as I remember, that's what the implementation does.
No, these are actual measurements, not simulations. There is a paper down here in the references that's a simulation. This is real. Basically, what should be happening is that the path that was damping is taken out of the best path calculation. I think we need to probably do more tests to verify this. I think you know where I live. Next. Sorry, oops, I'm sorry, this mic. Christian.
Hi, my name is Christian Panegi from Vienna University. I'm one of the authors of the RIPE 2229 and their predecessors. So I don't see really a chance to improve the aggressiveness of the parameters. I mean, we could do that, but when I'm looking at my routers and at the flap damping of my routers, I see a very big multiplication of flaps between, for instance, the announcements coming in through Sprint and the announcements coming in through Géant, Pulver Crossing, and other upstreams. So there is a difference of a factor of 10 over those 2 passes. So I think that both BGP, the way of BGP is doing announcements and withdrawals, and or the BGP damping algorithms should be changed. I don't see any improvement in tweaking around
The
the
numbers.
damping parameters. Probably. I would love if we could improve it that easy, but I'm sure
I think
it wouldn't help too much.
I think this is worth work. I agree with you. I don't have the answer. Sure.
Yeah, I just,
By the way, people should say who you are. I happen to know you all, but that's not fair to the audience who doesn't.
okay. Srihari, Rocket Networks. I just wanted to follow up on the comments, what NK made. Maybe I have not completely understood what the discussion was. In this slide, even though the dampening, okay, I'm talking about the deployed code base, even though the dampening information is maintained per prefix and per path of that particular prefix, if the contents of the S-path burst of what you have in the slide, the penalty is accumulated. So, is that what NK was referring to?
I guess we have to discuss this more.
Okay.
Hank?
Thanks.
Hank Atwa, RIPE CC. I just wanted to add that the RIPE CC RISC project has also set up 9 beacons. And if you want to know the IP addresses, look at my presentation of tomorrow afternoon. So lots of data, and we still don't understand it.
Unfortunately, those beacons don't seem to get much transit.
We asked everybody to accept them. I mean,
I understand you asked.
yeah.
Anything else? Cool.